Hello, this is IK Tutors, and we're here for another SHSAT question. So let's begin. Question states, given the partial table of values for f of x and g of x, find f of g of 3. Assume that f of x and g of x are the simplest polynomials that fits the data. Here we see a table with data, right? We have uh, coordinates, right? Now we have two sets of coordinates. They're sharing the x coordinate, right? So 2 points, two sets of points, but these points are sharing the same x values, right? So for the first one is f of x, right? We're letting y equals f of x. We have the first coordinate is minus 2, minus 16. Then we have minus 1, minus 2, 0, 0, 1, 2, and 2, 16. For the second set of coordinates, we're going to switch over to have our y values represented by g of x. So the coordinates would be negative 2, negative 11, negative 1, negative 8, 0, negative 5, 1, negative 2, and 2, 1. Okay, so now we have a set of points, right? And we're going to go ahead and what we're going to do is we're going to calculate or we're going to find for each function f of x and g of x, the appropriate polynomial, the general polynomial that describes that function, based on the data. So how do we do it based on the data? Well, it turns out there's a relationship between the differences of the coordinates to the degree of the polynomial equation, right? And that relationship is how we're going to tell. So what we need to do is we need to take the difference between the coordinates. Okay, so let's start off with f of x. We have from the table of data, we've labeled each of the coordinates, right? So we have x1 is goes with y1, x2 goes with y2, x3 goes with y3, so on. Okay. So what we're going to do first is we're going to take the differences. That's what this triangle means up here. It says delta of the x values. So it's going to be x2 minus x1. Right, so x2 value is negative 1, x1 value is minus 2. So we get x2 minus x1 is going to be negative 1 minus negative 2. Right, to get a plus 1. And we do the same thing for x3 minus x2. We do that. We get a plus 1 for that one as well. Do the same thing for x3 and x4. So we have x4 minus x3. And finally, we have x5 minus x4. Notice that we're subtracting the initial value or the previous value from the next value, right? So it's always the next value first. If we're looking at x4, we start off with x5 minus x4, right? So we have our deltas for our differences for our x's, and now we're going to go on to the y values where we have to take the differences as well. But with these y differences, we're going to keep going until we get a column that has all the same numerical values because there's a relationship between the type of equation and the data points and the what they call that when they have all the same values called a constant difference. So when we get a constant difference, that indicates that we have found the relationship for our data points. So let's go. Right. So y, we have y1 and y2. So it's y2 minus y1. We get plus 14. We have y2 and y3. So it's y3 minus y2. We get plus 2. We have y3 and y4. So it's y4 minus y3. We get plus 1. And we have y4 and y5. So it's y5 minus y4. We get plus 14. Now, if we look at our results, plus 14, plus 2, plus 2, plus 14, they're not all the same. Two of them, some of them are, but it has to be for to be considered a constant difference. All these numerical values have to be the same value. So since they're not the same, we're going to have to take differences again with these values. So we do the same thing with these values in the next column. So this is our second iterations, right? And we see what our results are. So we do delta. We call this, remember the triangle is called delta. So it's delta y2 minus delta y1. That gives us negative 12. Delta y3 minus delta y2, that gives us 0. And delta y4 minus delta y3, that gives us 12, positive 12, right? So again, we did not get the same values for all the differences. So we have to continue, right? So now we take the differences of these, and we get delta, 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 well, delta, delta y1, y2, sorry, minus delta, delta y1, we get 12, positive 12, and delta, delta y3 minus delta, delta y2, we get a positive 12. And then that's it. So for this column, we actually did end up getting the same numerical value for all the differences in the column, and that's what's called a constant difference. And that also indicates that this degree, this see the n, that's the nth degree polynomial. So this tells us that The third degree polynomial represents the relationship between the data points, right? And if it's a third degree polynomial, it's also known as a cubic relationship. So now that we have that information, we can go ahead and go to the next step, which is identify our polynomial, right? Because there's only one type of third degree polynomial. So we go down to the next slide, next table, and we see a listing of polynomials. And to the right of that, I'm sorry, the left of that, we see a listing of the degrees. N is the work represents the degrees. So it's n equals 0 degree and 1 degree, 2 degree, 3 degrees. So we see that n equals 3 is what we got. So we know that this polynomial right here is the polynomial we should be using, right? Again, it's a cubic. So now that we have identified the polynomial, the next step is we want to find the leading coefficient. What is the leading coefficient? Well, if you look at the first term on each of these polynomials listed here, the leading coefficient is always in the first term. It's that A. See that A? All the letters A. For the first one, 0 is A. For the next one, you have two coefficients, which is A and B. Next one, but the leading coefficient is always A. So there's a relationship between the constant value, the numerical value of that constant difference, and the leading coefficient. And that relationship is listed right here, right, as a formula. So if we just plug in that formula, the information that we've obtained, so we know n equals 3. We know in the top we have the actual numerical value of the difference, then we know we can just go ahead and plug in the values and we get what we need. So let's go ahead and do that. All right. So we know that the constant difference for this one was 12. So we're going to put 12 here in the top. And then we know that n equals 3. So we're going to say the formula is n factorial. So it's going to be 3 factorial, which means that we have 3 times 2 times 1, which gives us 6. So we end up getting for a equals 12 over 6, which equals 2. So we know the coefficient a, the leading coefficient a is 2. Now, we have to find the rest of the coefficients. So we're about at the end of this video as far as time, right? So this is part 1. We're going to go ahead and we're going to end part 1 here, and then we'll pick up the rest of the problem in part 2. So I hope this problem helped, this video helped. If it did, please remember to like and subscribe, and I will see you in the next video. Part 2 will be, the link for part 2 will be posted in the description, right? So you will have no problem finding it. Right? Have an amazing day.